All right, so are we alone? You know the big question. That's what we're diving into today.
One of the biggest questions out there.
And you've sent in a ton of stuff about exoplanets.
Yeah, it's a really exciting field right now. We're talking about planets that are orbiting other stars, and some of them, might be able to support life.
So Earth 2.0,
Yeah.
like pack your bags, find a good sunscreen, and head out to a new world.
Well, it's not quite that simple, but the search for planets like ours is definitely a big focus right now, especially with these space telescopes like Kepler. It's already found thousands of exoplanets.
Thousands, wow. That's a lot of planets.
Yeah.
So where do we even start?
Well, one place we could start is with Kepler 1649c. Imagine a world where the sun never sets, just constant twilight.
Ooh, permanent mood lighting. Sounds romantic. But wouldn't that mess with your sleep schedule? Like, seriously.
Yeah, you'd have to adjust for sure. But here's the thing. Kepler 1649c is almost exactly the same size as Earth, and it gets about 75% of the sunlight that we do. So temperature-wise, it might not be that different.
So, potentially livable. Plus, built-in mood lighting. I'm listening.
Yeah.
But there's got to be a catch, right?
Well, the catch is the star. Kepler 1649c orbits a red dwarf star.
Okay. And
Red dwarfs, well, they have a bit of a reputation.
for what? Being party animals?
More like throwing cosmic tantrums. They're known for having these really powerful solar flares that happen pretty frequently, and those flares can strip away a planet's atmosphere, even any water on the surface.
So, romantic twilight, but maybe also some cosmic sunburn?
Mm-hmm.
All right, maybe not so romantic. So what about this Earth Similarity Index I keep hearing about? How does that work?
Oh, that's a good question. The Earth Similarity Index, or ESI, basically measures how similar a planet is to Earth. It looks at things like size, mass, temperature, the type of star it orbits, all that.
So a cosmic scorecard for how Earth-like a planet is. Higher the score, the better.
Right. And one planet that got people really excited for a while was Kepler 438b. It got a really high ESI score, suggested it could be a lot like Earth.
So another Earth 2.0 contender.
Well, remember those red dwarf tantrums we talked about? Kepler 438b orbits, one that's especially prone to them. We're talking super flares, the kind that could really mess a planet up.
Yikes. So it's like living next door to a never-ending fireworks show.
Yeah, not exactly ideal. There was a lot of buzz when Kepler 438b was first discovered, but when they realized how active its star was, things kind of cooled off.
Well, it's a bummer.
Mm.
But hey, at least we're learning, right? The neighborhood matters just as much as the planet itself. So speaking of neighborhoods, what about our literal next-door neighbor, Proxima Centauri b?
Ah, yes, Proxima Centauri b. It's the closest potentially habitable planet to us. It orbits the star Proxima Centauri.
Wait, Proxima, doesn't that literally mean closest?
You got it.
So a close encounter of the planetary kind. Tell me more.
It's probably a bit bigger than Earth, and it's right smack in the habitable zone of its star, which means liquid water could exist there.
Okay, potential water, nearby star. Sounds good so far. What's the catch this time?
Well, Proxima Centauri b is tidally locked to its star.
Tidally locked. What does that even mean?
Imagine the Earth always showing the same face to the sun, just like how the moon always shows us the same side. That's tidal locking.
Okay, I'm picturing it. So one side always day, one side always night. That's got to make for some pretty wild temperature differences.
Yeah, exactly.
So-
And it makes you wonder about life there. Could anything adapt to those conditions? Could there be a sweet spot, a habitable zone in the twilight zone between those two extremes?
A planet divided. A constant battle between light and darkness. Okay, this is getting pretty epic.
It really is. That's what's so cool about exoplanets. Each one has its own story, its own set of challenges.
Okay, so far we've got perpetual twilight, angry stars, planets split between eternal day and night. What else is out there?
Well, let's talk about planets that are, well, supersized. Have you heard of super Earths?
Super Earths. Okay, so Earth but with a cape.
Not quite. Super Earths are planets that are bigger and heavier than Earth, but smaller than those ice giants, like Neptune.
Earth's older, stronger sibling. Okay, I'm with you. What's so interesting about them?
Well, there's one called Kepler 452b. It's about 60% larger than Earth, and it orbits a sun-like star right in the habitable zone.
All right, bigger planet, potentially habitable. I'm sensing a but coming.
You know me so well. The but is that Kepler 452b is about 1,400 light years away, so even if there's life there, it's not exactly a weekend trip.
1,400 light years. Yeah, that's a bit of a commute. But a girl can dream, right? Speaking of dreams, what about that planet that's like Earth's twin? KOI 4878.01.
Ah, yes, KOI 4878.01. It's got the highest Earth Similarity Index we've seen yet, 0.98.
0.98. That's not just a twin, that's practically looking in a mirror. What do we know about it?
Well, it's pretty much the same size as Earth. It orbits a star very similar to our sun, and based on the estimated temperature, it could have liquid water.
Seriously, so basically Earth, but maybe with slightly better Wi-Fi.
Well, maybe, but hold your horses. The data on KOI 478.01 is still being looked at. It hasn't been officially confirmed as a planet yet.
Oh, the ultimate tease. Dangles this perfect Earth twin in front of us and then makes us wait.
Science can be a bit slow sometimes. It's all about being thorough.
Okay, I can be patient, especially if it means we might have found Earth's doppelganger. So what happens now? How do we find out if KOI 4878.01 is the real deal?
More observations, more data, lots of analysis.
More waiting. It's a recurring theme.
Yeah.
But I guess that's how science works. Got to be sure, even if it delays our dreams of interplanetary travel a bit.
Exactly. And in the meantime, we can still explore all those amazing planets we've already found, like Kepler 62e and 62-6.
Wait, those are the water worlds, right? The ones that are basically just giant oceans.
That's right. They orbit a star that's a bit cooler than our sun, but still in that habitable zone.
No continents, just endless blue as far as the eye can see. I can only imagine what kind of crazy life could be down there.
It's definitely a possibility. And the fact that we found multiple planets with these huge oceans suggests that maybe these water worlds aren't as rare as we thought.
Huh? So maybe we don't need to find another Earth. Maybe we need to open our minds to other kinds of habitable worlds, like these ocean planets.
I think that's a really good point. We don't want to limit ourselves in this search for life. Who knows what's out there, right?
Exactly. This whole thing has been pretty mind-blowing, and we've only just started scratching the surface.
There are so many more planets out there, each with its own story to tell.
Well, then let's keep this deep dive going. What other planetary wonders are waiting to be discovered?
It's funny, we're always looking for these Earth-like planets, but we forget how special Earth really is.
You mean like how we have reality TV and pineapple on pizza? I mean, that's got to be pretty unique.
Those are definitely unique. Yeah, no, I was thinking more about Earth's moon.
The moon? Really? I thought that was just there to inspire poets and werewolves.
Well, the moon actually plays a huge role in keeping Earth's axis stable, and that's what gives us seasons. Without it, our climate would be all over the place, Extreme temperatures, really tough for life as we know it.
So the moon is like Earth's personal climate control system. Didn't know it was such a hard worker.
Exactly. And it's not just about stability. It helps with Earth's magnetic field, too. That shield that protects us from all that nasty radiation from the sun.
Okay, so the moon is basically Earth's best friend and bodyguard. I never really thought about it like that.
And that's something we should really keep in mind when we're looking for these habitable planets. It's not just about finding the right size and temperature. It's about the whole system. Moons matter.
So a good moon is a bonus point for a planet. Got it. So let's go back to the Earth Similarity Index for a minute. What's the highest score we've seen, besides that 0.98 for KOI 4878.01?
Well, another planet that had a pretty impressive ESI is Kepler 1649c. Remember that one? Perpetual twilight?
Yeah. The one that almost slipped through the cracks.
Exactly. 0.93.
Wow. That's really high. I can't believe it was almost missed, like it was playing hide and seek with us.
Well, it's true. It was initially missed because the signal was so faint. They only found it when they went back and manually looked through the data.
So sometimes it takes a human eye to see what the computers miss. Huh? Makes you wonder how many other planets are out there just waiting to be discovered.
Yeah, it really does.
So Kepler 1649c. Besides its high score and dramatic discovery, what else is interesting about it?
Well, its size and its potential temperature are both really promising. But like we said before, that star, that red dwarf, it's a bit of a wild card.
Right. Those red dwarf tantrums. They're like the terrible twos, but on a cosmic scale. So is Kepler 1649c doomed, just scorched by its star's outbursts.
Well, not necessarily. If it has a strong magnetic field, it could potentially shield itself.
Planetary force field for the win. Makes sense. What about the other planets we talked about? Any of them stand a chance, despite all the challenges?
Well, take the TRAPPIST-1 system, for instance. 7 Earth-sized planets around one star.
Oh yeah, the Cosmic Family Portrait. That one was wild. What's the latest on those 7?
Recent studies suggest some of them, especially TRAPPIST-1m, could have way more water than Earth.
Seriously? How much water are we talking?
Some estimates say TRAPPIST-1a could be up to 25% water by mass. For comparison, Earth is only about 0.02% water.
Wow. That's not an ocean planet. It's like a planet-sized swimming pool. I mean, can you even imagine what kind of life could exist there?
It's really fascinating to think about. I mean, we're so used to life as we know it here on Earth, but in that kind of environment, who knows what's possible?
I'm picturing these crazy glowing creatures swimming through these deep, dark oceans.
Yeah, it's definitely a possibility.
So lots of water, but maybe not the best conditions otherwise.
Yeah,
It feels like the universe likes to keep things interesting, you know? Always throws in a twist.
absolutely. That's what keeps this search so captivating. You never know what you're going to find next.
Well, I'm ready for the next big discovery. What else have we got?
Let's shift gears a little and talk about a planet that's a bit closer to home, at least relatively speaking. Have you heard of Proxima Centauri b?
Isn't that the one orbiting the star that's closest to our sun? Practically our neighbor.
Ah, that's the one. Only about 4.2 light years away. Makes it the closest known exoplanet to us.
Ooh, a friendly neighborhood planet. Maybe we should send over a welcome basket.
A welcome basket might be a bit difficult, but it is exciting to think that maybe someday we could study this planet up close.
All right, no welcome basket. Fair enough. But tell me more about Proxima b. What makes it so special, besides being close by?
Well, it's probably a rocky planet, a little bigger than Earth, and it orbits right in that habitable zone of its star, Proxima Centauri.
Rocky habitable zone. Sounds promising. But I feel like you're about to drop a butt on me.
Well, you know me pretty well by now. Proxima Centauri is a red dwarf star.
Ugh, those red dwarfs again. Always causing trouble. So is Proxima b doomed? Scorched by flares, no atmosphere, the whole deal.
It's definitely a possibility. Even though they're small, red dwarfs are known for being pretty active, and their flares can be really intense.
So Proxima b is playing a high-stakes game with its star. That's pretty risky.
It really is. And it reminds us that habitability isn't simple. It's not just finding the right size and temperature. It's about finding the right environment, a stable environment. And red dwarf stars, well, they don't have the best track record.
Got to be picky about our cosmic landlords.
Yeah.
Got it. But we shouldn't rule out red dwarf systems completely, right? They are the most common type of star in the galaxy.
That's a good point. And maybe, just maybe, life finds a way, even in those tough environments. I mean, we've seen it here on Earth. Remember those extremophiles?
Right, those little guys that love hanging out in volcanoes and deep-sea vents. If they can handle it, maybe life on a red dwarf planet isn't so crazy after all.
It's something to think about, for sure. And it just shows how important it is to be open-minded in this search for life. Life might be out there, just not in the forms we expect.
I'm all for being surprised,
Yeah.
especially if it involves aliens. So what other cosmic curveballs have you got for me?
Let's talk about a category of planets that sometimes gets overlooked in this search for life. Super Earths.
Wait, it's super Earths. I thought we already covered those. Weren't those just bigger versions of Earth?
Well, it's more complicated than that. They are larger and more massive, but they're also incredibly diverse. Different compositions, different characteristics. It's a whole category of its own.
Okay, so more than just Earth on steroids. Give me the details on these supersized worlds.
Well, one that's pretty interesting is Kepler 69c. It's about 70% larger than Earth, and it orbits a sun-like star right in the habitable zone. It's about 2,430 light years away, though.
2,430 light years. Yeah, we're not dropping by anytime soon. What makes this one stand out?
Well, some scientists think Kepler 69c could be a super Venus, thick atmosphere, runaway greenhouse effect, super hot, probably not very hospitable.
So like Venus, but even more extreme. Sounds like a planet best admired from afar.
Exactly. But even though Kepler 69c may not be a great place for life, it's still really important. Studying these super Earths, even the extreme ones, helps us understand how planets form and evolve, and that knowledge will help us find those truly habitable worlds.
So every planet, even the super hot ones, has a story to tell. It's like the universe is a giant library, and each planet is a book waiting to be read.
I love that analogy. And as we read more and more of these books, we're starting to see these patterns, these common themes that help us understand the bigger picture.
So we're not just finding planets, we're piecing together their history, their evolution. That's pretty cool.
It really is. And that story is full of surprises, just like any good story.
Well, I'm ready for more surprises. Bring on the next cosmic revelation.
Okay, let's talk about another type of planet that's been in the news a lot lately. Mini-Neptunes.
Mini-Neptunes. Now you're just making up words. What are those? Neptune, but pocket-sized.
Not quite. Mini-Neptunes are these planets that are kind of in between Earth and Neptune in terms of size and mass.
Right.
Bigger than super Earths, but smaller than the ice giants.
So like the middle child of a planetary family. Not big enough to be an ice giant, but too big to be a super Earth.
Yeah, that's a good way to put it. They're kind of a missing link, bridging the gap between those rocky terrestrial planets like Earth. and the gas giants like Neptune.
Okay, so important for understanding how planets form. I get it. But what about the big question? Could they have life?
That's where it gets tricky. Mini-Neptunes, we think they have these thick atmospheres full of hydrogen and helium, not exactly friendly to life as we know it.
So no mini-Neptunian aliens. Too bad.
Oh, don't rule it out completely. Some scientists think that certain mini-Neptunes might have layers of water under all that atmosphere, and who knows what could be living in those layers.
Okay, so an underwater world hidden under all that gas. That's pretty wild.
It really is, and we're just starting to learn about these mini-Neptunes. There's still so much we don't know.
I love a good cosmic mystery,
Yeah.
especially when it involves aliens. So tell me more about these mini-Neptunes.
One that's been getting a lot of attention is K2-18b. It's about 2.6 times the size of Earth, and it orbits a red dwarf star about 124 light years away.
Another red dwarf. Is it just me, or are those things everywhere?
They are incredibly common. Something like 85% of the stars in the Milky Way are red dwarfs.
Okay, so maybe we need to get used to these red dwarf systems, even with their cosmic tantrums. So what's special about K2-18b, besides the red dwarf thing?
Well, it's one of the few mini-Neptunes that we've been able to really study, and what we've found is pretty interesting.
Interesting how. Don't keep me in suspense.
We've detected water vapor in its atmosphere.
Water vapor, like what clouds are made of. Why is that a big deal?
Well, when you find water vapor in a planet's atmosphere, it's a good sign that there might be liquid water on the surface. And liquid water, as we know, is kind of essential for life as we know it.
Okay, I see where you're going with this. So even though K2-18b is this gassy mini-Neptune, it might still have liquid water under all that gas.
Exactly. And that opens up all these possibilities for life, even on these planets that we might not think of as habitable at first glance.
So even the least likely candidates can still surprise us. It's like the universe is telling us, don't get too comfortable with your assumptions.
And that's what makes this search so exciting, right? It's all about discovery and challenging what we think we know.
Well said. This deep dive has been amazing so far. I feel like we've only just scratched the surface. What other cosmic wonders are out there?
You know, we've talked about all these different types of planets, but there's another thing that's really important when we're thinking about life, something we touched on before, magnetic fields.
Magnetic fields. Like the Earth's magnetic field. The thing that makes compasses work. What do those have to do with life? I always thought they were just for, not getting lost.
Well, they're actually much more than that. The Earth's magnetic field, it's like a giant shield. It protects us from all that radiation coming from the sun and from space in general. Without it, life on Earth would be very different, maybe even impossible.
So a magnetic field is like a planet's personal force field, deflecting all that bad stuff.
Yeah, that's a good way to think about it. And how strong a planet's magnetic field is depends on a lot of things, like what it's made of, how fast it rotates, even if it has a moon or not.
Wait, the moon can affect a planet's magnetic field? I thought the moon was just, pretty to look at and responsible for werewolves.
The moon is more important than people realize. Its gravity helps keep Earth's rotation stable, and that stability probably helps make our magnetic field stronger.
So the moon is like Earth's magnetic field booster. Pretty impressive for a giant rock.
It really is, and it just shows you that habitability is complicated. It's not just about the planet itself, it's about the whole system, the moons, the magnetic field, how the planet interacts with other planets. It's all connected.
Wow. This whole search for life is way more complicated than I thought. It's not just about finding another planet that looks sort of like Earth. It's about finding a planet with the right combination of things, the perfect recipe for life.
Exactly, and that's what makes it so challenging, but also so rewarding. Every new planet, every new piece of data, it helps us learn more about the universe and our place in it.
I've got to say, this has been a real eye-opener. I used to think of planets as these distant, almost imaginary things. Now I see them as these complex worlds, each one unique.
And who knows, maybe some of them have life as we know it. Maybe others have life that's so different we can't even imagine it.
The possibilities are incredible. And we're really just getting started. It's exciting to think about all the discoveries that are still to come.
It really is an exciting time.
I totally agree. And thanks to you, I feel like I'm actually starting to grasp all this exoplanet stuff.
Right.
It's not just science fiction anymore, It's real. And that's pretty amazing.
Well, thank you. And remember, this search for knowledge, it's like the universe itself. It never ends. So keep exploring, keep asking questions, and never lose that sense of wonder.
I will. And to all you listeners out there, keep looking up at those stars and keep dreaming about those distant worlds. Who knows? Maybe one day we'll be packing our bags for a trip to Earth 2.0. Until then, stay curious.